welcome everybody. I'm super excited to be here. Welcome to the very first OpenVEX project update. Right, there we are. Yeah. So yeah, my name is Adolfo García, or Puerco everywhere. I am one of the maintainers of OpenVEX, and I am also a software engineer at a company called Chainguard. And I also do a couple of other open source things. One of the people from Kubernetes, where I'm one of the technical leads with SIG release. And we're the people that bring you Kubernetes every month. And I especially work on the release tooling. I worked on some of the signature stuff on the SBOMs. This year I'm sitting also on the Knative steering committee as an end user of the project. I also maintain a bunch of other, mostly SBOM related tools. And I also became a cloud native ambassador, but I haven't had enough time to really fulfill that duties, but yeah. And I'm also a bike nut, so if you like traveling on your bike, please come talk to me about this or OpenVEX. So before we go, also I'm very, very badly jet lagged, so if I start Englishing bad, just apologies in advance. So before we start, I would like to do a quick show of hands because I would like to know how many people here know about VEX, have heard about VEX, are using or considering. Oh, well, that's extremely satisfying to see. Okay, so I'm going to do just a quick, super quick tour about what VEX is. Just because I had a planet and I wasn't expecting so many people to be familiar with it. So VEX, VEX, or the Vulnerability Exploitability Exchange, is a system, a sequence of statements that convey information about the impact of a vulnerability on a piece of software. And not only about the impact, but also the knowledge as the information evolves. Contrary to popular belief, VEX is not SBOM. It is related to SBOM, and VEX can gain some very awesome superpowers when paired with SBOM, but it can also operate independently of SBOM. And the current shape of SBOM is being coordinated by the VEX working group, coordinated by CISA. So let me give you a super quick example of one of the situations that VEX can handle. So take a software supplier and a software consumer, and by software supplier, we can think about a project, an open source project, or a big company putting out some software release. And we're talking about a serious and responsible company that cares about having a low CV count in the releases. And when they release software, they also put it out with an SBOM. So whenever you got a release of your product, the software consumer will most likely, if it's someone responsible and not the sad, sometimes current state of affairs, will actually look at that SBOM, scan it, and see, try to understand the dependency graph of the software that you just handed to them. And most of the time, that customer will find out that there are more vulnerabilities in the software that they just acquired than they were expecting. So the end user will go back to the software supplier and say, well, I have a bunch of problems with this software because it's full of CVs, and the supplier will go back and say, well, yes, we may have some, but most of them you should not really care about them because they're false positives. Some of them are due to name mismatches. Some of them do not apply to your current platform. Some of them will never get executed. We saw a bunch of like real-world examples in BenSoc just before. And in this communication right now mostly happens verbally or in other mediums which are not machine readable. And the customer, well, they are simply expected to just trust the supplier's word for it. And you can trust it because you're executing their code in your systems anyway, so, well, just take the word for them. But the real problem that arises from this situation is that it creates a lot of noise when you're trying to triage those vulnerabilities. And this is where VEX comes in to help. So what VEX does is that it creates, VEX defines a series of documents and those documents contain statements, and those statements capture the knowledge of a vulnerability's impact on that software. And those statements, their only purpose in life is just to make your security tools happy. What does a VEX statement look like? A VEX statement pairs together 3 bits of information. The first one is a software package, which we call in VEX lingo the product, a vulnerability, and a status. And the statuses can convey 3 basic meanings. The first one is that, yeah, that vulnerability affects your piece of software, so you're vulnerable. And the VEX statement can also give information on what you should do next with that vulnerability. Maybe apply some mitigations, and you can embed, in addition to the machine-readable part of the VEX statement, you can also embed information that may be surfaced to the user by the VEX processor, which may be a security scanner, for example. The second one is you may not be affected, and the not affected status is also paired with a machine-readable justification. And these justifications are there are about 6 or 7 of them. They include things like the software supplier already applied some mitigations, this is not in the executable path, it's for another architecture, and various others. And finally, the VEX statement can convey information that the software supplier is aware of the vulnerability, but it's looking into it, so it's under investigation. And to make VEX work as a system, you need to add 2 more things. The first one is the chronological element. So VEX statements are a sequence, so when you start issuing them, you need to take into account time. And the second one is machine readability and automation. This is what an OpenVEX statement looks like. So this is a whole document, so it's a simple one, but it's fairly complete. So you see the vulnerability almost at the top in the first statement, the timestamp of the statement. Then in the first line of the product is a PURL of a container image. This is the latest Alpine image, and then 2 components, the 2 subcomponents of that product. And the status at the bottom is not affected. Why? Because inline mitigations already exist. This is just a made-up statement, no correlation with reality. So going back to our use case, the idea is that the next time that software supplier hands over the product and the SBOM to their customers, they can also hand them over a VEX document. And that VEX document has information that would have otherwise would have been picked up by the security scanner as a vulnerability. But the software supplier, which is a trusted entity, reads that information and suppresses the alerts on the vulnerabilities. And to give you a sense of why this is so important, I'm going to show you this graph here. My company, one of the products that we have are secure container images, and we try to keep the CV count on those images always as close as possible to 0. And this is a fragment, a sample of the data that we generate from those images. So we scan all of our images and capture the CVs because our engineers can then handle and triage them. And as you can see here, the big band in the middle, the green one, are the false positives that we are getting picked up, that we pick up in those images. And as you can see, it's more than half. So I hope that convinces you that why we need VEX in the world. And now the other question, why OpenVEX? So to understand why we need OpenVEX and why we decided to come up with this project, we need to go a little bit back in history. So VEX itself was proposed among the SBOM working groups coordinated by CISA and NIST back in 2020. And in those groups, people who were already working with SBOM started to distinguish and really foresee the need to better communicate vulnerability impact on software. And folks in the user group started to come up with the statuses that we wanted to see, the shape that the data was supposed to be structured. And the first ones to adopt those decisions were CSAF, the Common Security Advisory Framework in OASIS. So they started taking those decisions from the community and building what eventually became the CSAF VEX profile. While this was being done, SACLON-DX came up with their own version of VEX, which was, in the beginning, it was really incompatible. Now with 1.5, it has become a little bit more compatible. But out of, I won't say frustration, but just to make sure that we were all handling the same data, the VEX working group started working on the minimum elements for VEX document. And that is not a specification, but it's rather a spec of specs, which defines the fields, the constant, and the structure that the document and the statements need to have in order to be VEX. So if you want to create your own implementation of VEX, you need to follow those guidelines. And that's where the OpenVEX project came from, by implementing that data format. So by the end of this community process, we ended up with what is now 4 implementations of VEX. You saw Seth in the Python talk mentioned that the formats are not really important, but just to make sure that we're talking about the same information, and it's the same case here. In theory, we should be able to move information from any of the VEX flavors to the others. In reality, it's not 100% true, but it mostly works. In OpenVEX, we have libraries to ingest, for example, CSAF. So if you have a CSAF advisor, you can ingest it and then continue the flow of VEX in OpenVEX if you want to. And the others may be coming soon. And you may be asking, well, if we have these 3 well-known names implementing VEX, why add another one? And the reason is, well, sometimes it's fun, I don't know, it's useful to be part of large user groups like this ones. It's like being in a family because you get all of the love and support from the family, but you also inherit all of the quirkiness from that family and also the weird family itself. And what I meant by this is, the idea here is we started seeing, and by we mean the original maintainers of OpenVEX, we started seeing that some of the decisions in VEX were being driven by very powerful voices that were trying to steer things to make sure that their realities today were being addressed, and not necessarily thinking on the problems that VEX was eventually and will eventually run into. And these are more complex problems, such as capturing data in a format. The format is really not important, and if you saw that chart where we can flow information from one to another, that should make it clear. So a bunch of friends from different companies, we started some discussions about how VEX should be more lightweight, how VEX should be more embeddable, how we wanted to make sure that VEX rose above the SBOM drama in the war between the formats. And by the way, I say this, it's a subject that I really care about. I'm also one of the contributors to SPDX, which is having its own bash down the hall there. So we started there were some fundamentals. So before we started OpenVEX, we started prototyping, creating some tools to see if VEX was viable or not. And we started seeing some very fundamental issues with the way VEX was being drafted inside of the formats that we thought that needed to change. So the first one was speed and cadence. So while some people saw VEX as a big organization, I don't know, suddenly erupting one slow-moving VEX document, here it is. We saw VEX as a more dynamic, moving as like shifting as all of the software supply pieces change, that information should also change. And to enable that change, we needed a linear format. We needed to quickly develop tools to enable software authors to VEX, you know, in a more developed DevX-friendly way, because you need to keep into account that the other formats, usually you see them adopted in big corporate enterprise projects, and what we wanted was to give the open source smaller projects tools that they can just download and use. The second one was we didn't agree a lot on that idea of VEX should be issued by one person. So it's a supply chain, and we consider that VEX should many parties in the supply chain should be able to add VEX data into the chain. So whenever you publish a document, that document and the statements contained in the document may be coming from another link in the chain, from your libraries, from security researchers, from trusted open source maintainers. They should also be able to VEX, and you should be able to consume those statements and reuse them in your own document. So we see it as a collective effort. And finally, the last one, which was, I don't know, I think the group eventually saw the light in this one, but we emphatically saw the need for VEX to be a machine readable. There was a big push from some of the parties in the VEX community that wanted to shape VEX into what was more of a web page, for example, like you put out a JSON that only contained information for humans to consume, like the explanation of like an advisory. This is why you're not affected, read it and be happy with it. And we saw it like, no, we need to make sure that this is machine readable, that machines can consume this securely in a trusted fashion so that you can create automated systems that process VEX. And the most important one is we wanted to make sure that VEX was future-proofed. While all of the debate of the data structure, the formats that were implementing it was important for sure, the most important part of all was making sure that the format enabled the future use cases for VEX, enabled solving the future problems that VEX is about to start solving right now. And it was important for us that VEX did not fall prey into the limitations of the current formats. And by future-proofing, we mean, first one, that VEX is discoverable, so you should be able to just take a software component and magically locate all of the VEX documents that apply to it. The second is it should be trusted, and by trusted I mean if I'm running a security scan and my scanner is ingesting documents, I should be able to do that process without even knowing. The security scanner should be able to locate those documents, consume them, and trust them without me having to approve anything. And finally, we wanted to make sure that VEX was embeddable. And this is important because we really wanted to make sure that VEX documents could be embedded in other formats, especially and most importantly to sign and attest them. And so we took our prototypes and cleaned them up a little bit, started to write a formal draft on what it should be, and after a very friendly discussion, we donated the project to the OpenSSF, the vote came through, and the project was accepted. And so we now have the OpenVEX team. So let's talk about a little bit about the project, what it does. So what does VEX do for the open source in general, besides having the coolest goose mascot of them all? So the first thing that I need to make sure my message gets across is that OpenVEX is way, way more than just a spec. I know some of the discussions around if you jump today in one of the VEX calls, some people are saying like, oh, we need to write use cases and theoretical things. No, OpenVEX has today working tools, and we're going to see some of them. Of course, we have a specification. It just went under its second somewhat major revision, its first breaking change after 4 or so months of gathering feedback from the community. We also have maintained a Go library. And the Go library does much more than just ingesting and serializing documents. Our Go library lets you match vulnerabilities, match software identifiers. It lets you merge documents, add and maintain them, so a bunch of other things. It's not just a dumb JSON serializer. In addition to that, we have community projects that implement OpenVEX. We have one in Rust, one in C# for .NET, and as of yesterday, I think, someone pinged us that they have a Java version, which was amazing to see. And finally, we have tools, working tools that you can download and use. The main one is VEXCTL, and using VEXCTL, you can create documents, you can add information to those documents, you can create them, you can convert them into attestations and sign them using Sigstore. Right now, there are two big efforts, and I was really not sleeping trying to get the SBOM integration working. And that one is going to be pretty cool because the idea is you ingest an SBOM, and the libraries are going to find all of the related documents and mix them into one final VEX document before assembling the VEX document for your product. Those are the plans. And the other one is a data backend for VEX, because as some of the early testing has demonstrated that the data in VEX starts to pile up really quickly. So what I want to see in the project is that the libraries handle all of the data management for you so that you don't have to care about that. So if you're writing VEX processors or VEX writers or whatever, all of the data is handled for you. The project has also been working on documentation. We started like 2-3 weeks ago in coordination with the overall VEX working group, push to start creating how-tos and use cases to show users how to handle the basic situations of VEX and going all the way up to the more complex ones. We wrote a guide for scanners, for security scanners, so if you're writing a security scanner, you want to implement OpenVEX, the guide tells you what the project does and tries to paint a clear line where the project's responsibilities end, and you should implement the rest. And we're also working on some case studies. The latest one that we published, well, this came out as a blog post from my company, but the idea is to start collecting case studies. And the latest one was with Isovalent. And if you want to see how Isovalent is using OpenVEX in production today, you can read that. I don't know, I think it's pretty cool. But the most important part the most important work that we're doing is we're trying to solve the chicken and egg problem of VEX. So if you think about VEXCTL, that solves the generation question. But you have, with any new format, you have the question because there's a lack of incentives. Should I publish my information in this format? Well, no, because there are no processors. Should I create the ingestion system for these documents? No, because there are no documents. So we're trying to tackle the problem from both sides. And to do that, we're starting with the first and most widely used and obvious consumer, security scanners. So the first one to adopt OpenVEX a couple of months back was Trivi from Aqua. So they built OpenVEX support in Trivi, so you can ingest those documents and use them to polish your scanning results. The second one, as of last week, we now have support in Gripe. You can scan your container images, and you can ingest those OpenVEX documents, and they will help you lower the false positive rates or augment the results if you want to. And of course, we want to see the three most widely used scanners supporting OpenVEX. So we are waiting for the third one to show up. And no names will be named during this talk, but perhaps you know who I'm talking about. So no, just kidding. So Snyk was one of the first and earliest contributors to the project. Since we began, Snyk started opening issues and adding valuable suggestions, and we're hoping to work with them next to improve the project. And finally, I wanted to show that all of the hard work has been paying off. So practically all of the indicators of the project have been going up. We've seen more pull requests, more contributors, GitHub stars, projects depending on the OpenVEX libraries have been going up, which is also great. And yeah, and finally, before I left, I had a demo plan, but I was suspecting that I didn't have time to do it. But yeah, I want to go just to the final slide. So here are some resources. This is the OpenVEX SIG on the OpenSSF GitHub org. We have bi-weekly meetings. So if you want to just hang out or want to contribute or want to have questions on the project, please show up. All the Vexers are a very, I don't know, happy, friendly bunch, so we will be happy to have you there. We have a bunch of blog posts, and if you want to get a hold of me, I'm Puerco in most internet things. And before we go, I wanted to just say thanks to two very special persons. Yeah, the first one is Art Manion, the perennial single co-chair of the VEX working group, who's always looking for another co-chair to help him out. And of course, our beloved Krob, whose help we couldn't possibly run the meetings and the community successfully. So that's it for me, and I hope you enjoyed the blog. Just before I go, if you want to see all of these things in action, I'm doing a deeper dive into the OpenVEX and its tooling on Wednesday. I don't remember the time, but it's there on the schedule. And we're going to talk about SBOMs and OpenVEX in detail. So thank you.
We do have time for some questions, Adolfo. If you have a minute, yeah? Okay, I know we've got a few in the audience.
Chaos. No. I love what you're doing. One of the things about VEX that has vexed me is people weren't necessarily interpreting things the way I would, and I'm glad there's another player looking at different ways of looking at things. One of the problems, and this isn't specific to OpenVEX necessarily, but I'd love to get your perspective on VEX is going to be great for saying, oh, hey, this tool gives the wrong version for this, so ignore it, or hey, we're targeting our stuff for x86 and this CVE is only for ARM. I'm more concerned about the corner cases where, hey, this is a vulnerability in a C++ library, and my experience with development teams being able to actually truly say whether or not that code affects them or not are problematic at best. Generally, they don't necessarily know whether a function is really called or not, because they don't test all the cases and they don't necessarily see, oh yeah, there's a function pointer that goes to this function as well. So I'm curious about your thoughts for those corner cases.
Yeah, well, that's why we wanted to make sure that VEX information could be automated, because one of the possibilities that we have and people are already working on is runtime analysis of projects and other kinds of automated analysis that give you that information, and they can be funneled back as OpenVEX statements. So if you choose to incorporate those into your results, OpenVEX will mix them all together to do a final call. So you may have a VEX statement that says, okay, this is not affected, or just nothing at all, run an automated tool, and that emits a VEX statement that gets into the flow, and that gives you another outlook on those. So no, it's not always a human call behind the VEX statements. It can also be the result of automated scanning and other processes.
You said that discoverability was one of the goals of OpenVEX. How does that work?
So there are a bunch of ideas. So one, I have a demo of a library that starts to take care of looking at a lot of so you feed it PURLs, and it will try known mechanisms and cache those information, the information that it finds to find that. That's one. One of the other things that we're looking at is WAC. So using WAC and querying WAC databases that already know how to find those. And finally, the other mechanism that we have, well, we have two simpler ones, which is one, attaching those documents into the container images, Sigstore style, and the other one is just laying them down in the GitHub repository. So via the SBOM, you can locate the GitHub repository and pull that. Of course, there are many, many different use cases. So what I want to build into OpenVEX is a library that captures all of the practices that people have to locate those documents and then try them all when you try to locate them via an identifier.
Thank you, great presentation. You mentioned machine-readable information that should be incorporated into VEX, and that's great. From your experience working with different vendors, have you seen any additional meaningful information besides just, okay, inline mitigation exists, that's cool, but any other additional, let's say, human-readable information, why? Like description, long story, justifications, something. What's your perspective on the readiness of this, let's say, openness from vendors to share more information? Thanks.
So you mean in VEX itself, or just the information that?
In VEX itself, yeah.
So if I'm understanding the question correctly, do you mean if VEX needs to improve their justifications and things like that to capture more use cases?
Yeah, it contains the description fields. Basically, you can state whenever you want. So do you see any of these cases, or just machine-readable fixed fields like not affected and one line?
Well, I guess it depends on who's issuing the VEX statement. So
from your experience, yeah.
Yeah, so for example, in my company, we have a Linux distribution, and the Linux distribution project issues its own security advisories, for example. And those advisories have more data than VEX can handle. And the idea is that we can capture and translate some of the status that we have in the advisories into VEX, and also capture the human-readable blurb into that. In the case of more automated tools, they may not be able to give you more context, but basically a bunch of predefined messages maybe. But I guess it all depends on who's issuing that information.
And currently there's only
Okay.
a handful of vendors issuing VEXs, so that's part of the rationale behind the project is to get more people using VEX so we can do some analysis, understand what we need to change.
Yeah, in case if there is a clear connection to advisory, that is, yeah, that makes sense, yeah, thanks.
Any other questions? All right, let's give another round of applause.
Thank you.